I'm going to start this by asking you to draw the Lewis structure of oxygen. So pause, go ahead. Anytime that I give you a structure to draw, pause it, see if you can get it, and then compare it to mine. So oxygen is pretty simple. There are 2 oxygens for a total of 2 times 6 electrons, so 12 total valence electrons. That's what I'm shooting with, okay? So there's no central atom. I'll connect them by a single bond. I'll fill in their octets. And now I'm good, right? No, because I forgot the most important step ever. Just count the electrons. 2, 4, 6, 8, 10, 12, 14. 14 electrons. So boy. Okay, well, what are we going to do? Well, what's going to happen here is that instead of sharing 2 electrons, oxygen is actually going to share 4 total electrons. And remember, each bar indicates 2 shared electrons. Okay, so now this oxygen has 2, 4, so it only needs 2 more. Okay, don't worry about the positioning of these for now. And this one also needs 4 more. So that's 2, 4, 6, 8, 10, 12 electrons, and that's what we're looking for. Okay, the dot structure of this would look something like this. Kind of funky looking, where instead of sharing 2 electrons, we're now sharing 4 total electrons, right? Okay, so this is an example of multiple bonding, okay? And one of the hallmarks of multiple bonding is when you go through the steps for VSEPR, or for writing Lewis structures, you'll see that you'll often end up with more electrons. Now, last class we did an example where we ended up with not enough electrons. All right, so those are your sort of 2 possibilities for getting wrong counts. You can have not enough electrons, or you can have too many, or you could have the right number. That should make sense. Okay, so double bonds are often found in compounds containing nitrogen, oxygen, or carbon. Okay, they're very common in those compounds. All right. So one of the things that we'll talk about a little while later is that because we're sharing 4 electrons instead of 2 electrons, multiple bonds are actually stronger than single bonds. And because they're stronger bonds, because they're sharing these 4 electrons, the 2 atoms are actually closer together, and it takes more energy to break the bond. We call that bond energy. But we're going to go into all of that much more later. Okay, I just wanted to kind of draw your attention to that. So why don't you try these 2, CO2, which is carbon dioxide, and CO, which is carbon monoxide. So carbon dioxide is one carbon. 1 times 4, 4, that's 2 times oxygen, 2 times 6 for a total of 12, so that's 16 electrons. So here I do my carbon with a single bond here and a single bond here. I fill in my octets. And then I count and I'll get 20 electrons. Now, one of the things that people try to do is they try to fill up the number, like the number of electrons they need as they're adding them in. So one of the things that I see commonly as a wrong structure, or a bad Lewis structure, is something like this, where I've got 16 electrons now, but carbon doesn't have an octet, and that's real bad. Okay, so carbon needs to get those electrons in. Okay, so that's wrong. So let's try instead, let's try one double bond and just see what happens. Okay, so now this has 4, 6, 8. This has 6, so it just needs 2 more. And this needs 6. All right, so count them up, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, still not good, so we need another where, let's say we go a double bond on this side, a double bond on this side. This is 16 electrons. That makes me happy. So this is my correct structure for carbon dioxide. Okay? Maybe I could do it with a single bond on one side and a triple bond on the other side, but you need 2 multiple bonds. Okay? So let's keep in mind, let's look for a pattern here, right? I'm big into patterns. So we're going to do carbon monoxide, and then I want you to look for a pattern in carbon monoxide. Okay, so carbon monoxide, that's 1 times carbon. It's 1 times 4, that's 4. And this is 1 times oxygen, so that's 1 times 6 for a total of 6 and 10. Okay, so I do my carbon monoxide, 2, 4. And I get 14 electrons. Okay, that's too many, so let's try having 2 bonds. That's called a double bond. And this time I'm going to have 12 electrons. And then, okay, so that's not quite right yet. So let's go to a triple bond this time. And now I've got 2, 4, 6, 8, 10. 10 electrons. Yay! So that's the one we want. Okay? So let's look at the pattern here. All right? Every time that I add a multiple bond, so whether it's going from like a single bond to a double bond or going from a double bond to a triple bond, every time that I add a multiple bond in, I decrease the total number of electrons by 2. Okay? So that's something that you can use to be kind of a predictor of what you need to do. All right? Good? Great? Wonderful? So let's